All right, so we've talked about symmetry, and a reflection is basically making a new function that looks symmetric in some way to the original function. So here, we've got our picture, we've got our water, our hot air balloons, and kind of the surface of the water is kind of our reflection, right? We're reflecting what's in the air above the water down into an image that's below the water. So, we're reflecting the graph across the x or the y-axis. So here, if we simply make our y to be negative, there we go. If we make our output of the function negative from what it would have been, we're just reflecting the graph across the x-axis. So the graph of y equals negative f of x, that's taking our original graph, reflecting it across the x-axis, because all the y values become the negative of what they were. If instead we say, okay, well, we're making a new graph that has the negative input, that's a reflection of the original function across the y-axis. So we'll look at reflections across the x-axis first. There we are. So we've got y equals x squared minus 2. So we see the minus 2 there. We know that this is going to shift our toolbox function of y equals x squared is going to shift our function down 2 units, right? So the question is going to be, okay, what is the graph? So there's our quadratic, our parabola that's been shifted down 2. So if I tell you, okay, I've got this graph, this function y equals negative of x squared minus 2, what is that doing? Well, we're just taking all the outputs of the original function, x squared minus 2, and flipping the sign on them, right? So here where I have 0, negative 2, we should have 0, 2. My x-intercepts are going to stay the same, but my negative 1 point is going to become 1, 1. My negative 1 point is going to become 1, 1 also. And I can kind of sketch from there. We can say, oh yeah, we're going to meet, well, we'll try. Oh, there, it came up for me, right? So this is just causing a reflection because we have this negative outside of the function reflect over the x-axis. So this is another outside change. It's changing your y value from positive to negative in this case. That's all we're doing, reflecting over the x-axis. So if we look at a reflection over the y-axis, so this time we've got our x minus 3 quantity squared. And so this is, we can think of this as we have our original toolbox function, y equals x squared, and we made a change, an inside change to it, right? So we're starting off with that. So this is saying, hey, that this is taking our parabola and shifting it right 3 units, right? So what's that going to look like? There we are. We've got our original parabola. Our vertex has been moved from the origin to 3, 0, and every point there has been moved 3 to the right of what it originally was. Now, what if we say, hey, I want to define a new function, and it's going to be f of negative x. So everywhere I've got x, I'm going to put in negative, right? So this here is going to take that function and reflect it over the y-axis. All right, so where we had, so for instance, where's my 0 going to be? What value of 0 am I going to plug in, right? If I plugged in negative 3 minus 3, I'm going to get positive 3 minus 3, that's 0. So there's my new vertex, right? And that's all we're looking at there. So we are reflecting over the y-axis. And we can see, there we are. I didn't quite line those up, but you get the idea, that we've got that. Now, let's see here. So next up, we're going to talk about vertical stretches and shrinking. So again, we're building the pieces, and then we'll get some more complicated problems putting multiple transformations together. But we're going to call this a break before we move on to stretches.